This week we're going to be taking a look at sets within Swift, and this is a data structure that is similar to an array, but it has a lot of differences as well. And the reason why we're going to be looking at sets is because when we get to looking at our tap gestures with our sprites, this is going to be using a set, so it bodes that we should have some type of familiarity with what a set is before we get into dealing and using a set for those tap gestures. Now, if I look at a set, I can create it with an array of items. I can go ahead and add things to my set, similar to how I can add things to an array using an insert. Unlike the append for the array, we have the ability to remove an item from the set as well. It also has some differences from the standpoint of when we store an element within a set, it's going to pick a random location within the set to place that item. It doesn't necessarily use any indexed location like an array does to place an element. It's just going to put it somewhere. So we can't count on the order of the elements that are placed within that set. When we get into trying to store duplicates within a set, it's not going to store the duplicates. We're not going to necessarily see errors pop up when we try to do it. It's just going to ignore it since there's already one in the list, and it's just going to go ahead and say nope. And it's going to always maintain a unique set of items within the list, no duplicates. Unlike an array, we could store duplicate items. We have the ability to do some additional types of operations, like we can check to see if an element is contained within a set using the contains operator. We can use the is subset. This is basically going to be where we take one set and we check to see whether it is a subset of a second set. And that's basically where it's checking to see if all elements within the first set exist in the second set. And then we can take a look at an intersection. This is where we're going to create a set of all the elements that exist and are common to each of the two sets that are being used in the intersection command. And then we can look at a subtracting, which essentially is going to create another set of elements. And this is where we take our first set that we're using to subtract the second set. It's going to then return to us a list of those elements that belong in the first set that are not in the second set, in case we would want to do this. So very, very math-like in nature on sets. If we start looking at the code, I'm going to go ahead and get into Xcode here. Bring over my window, and I'm going to start with a set. I'm just going to copy it over and paste it in, and I can go ahead and I can print out my set using a print statement, similar to what we've been doing with other types, except it would be nice if I actually used the Swift command there. And we can see the elements printed out. Now, if I decide that I want to go ahead and I want to add another color that's one that's duplicated, I can go ahead and do a colors.insert, and we already have red in the list. Let's go ahead and add red. And then if I go ahead and print out colors after, we should see that there's only one color in the list. So let's save this. Go ahead, execute this. It doesn't kick us back with any errors, but notice that it only has one red within the list. We have the first one for our first print statement and the second one that has just one red. We're not getting that second one that we added. It sees that we already have one in the list, and so it's basically not adding it to the set. It's just saying, yeah, you already got one. It's got to be unique, so I'm just going to ignore it. Now I could go through and do something where I'm going to add colors.insert teal, which is like one of my favorite colors. I can come up here, put it above, save it, and then if I rerun this, I should see that it does add teal because it is unique. It's not already in the list, and I can then go ahead and do that. So then if I go ahead after I print out something and say I really didn't want to put teal in, I can go ahead and remove teal from the list. And then if I print it out again, I should see that it's no longer in the list. So if I save that, we see that now teal is gone from the third iteration. Now that gives us a lot of different capabilities. I'm going to just comment out some of this so we're not printing out so much stuff. I want to bring in a second set, and this is going to be one that I can use for primary colors. When I'm trying to look at the two sets together, I'm going to use this one. So I'm going to bring this over, and it's just going to be the primary colors, red, blue, and green. And in this case, maybe I want to check my primary colors to see if blue is in that set. And I can just go ahead and define a Boolean. So I'll make this blue exists. This is going to be of type bool, and we can do primary colors dot contains blue, and then I can go ahead and say something like print primary colors contains blue. And then using string interpolation, I can type out whether blue exists or not. If I go ahead and save this and then execute this, I should see that it's returning true, that blue does exist in this set. And I should see that blue does exist in the set. Now if I decide that I want to look at the intersection, which is where I have items in both, it's going to return to me a set. I can define items in both, and this is going to be a set of type string that it's going to return. And I can do the colors dot intersection and pass in primary colors, and then print out intersection using string interpolation, items in both. If I save this and rerun it, I can see that blue, red, and green are in both of the sets. I can also check to see if my primary colors is a subset of my colors, and I'm just going to do this using is subset of colors. This is going to return a bool, and this is going to be primary colors. So this is the subset that I want to check in the other set. So is subset of, and then I would specify the colors, the set that I'm checking against, and then print out is subset using string interpolation is subset of colors. I save this and rerun it. We can see that it is a subset. So every element that I have within my primary colors also exists within the colors. If it had like cyan, maybe if I had like red, blue, green, and cyan, and it didn't have cyan here, it would not be a subset. Now, if I decide that I want to check to see the colors that exist in the colors set that don't exist in the primary colors, I can do that using the subtracting, and I'm going to use a really long name here so that it's descriptive. So items in colors, not in primary colors. That's going to be a set of string, and set this equal to colors dot subtracting, and this is going to be primary colors. And then I can go ahead and I'm just going to print out this name because I don't want to, it's already long enough. And since we have everything else labeled, it should be pretty indicative of what this is. Now if I go through and execute this, we can see that black, white, orange, purple, pink, and yellow are the colors that do not exist in the primary colors that exist within the colors. So that's our subtracting. So hopefully this gives you a little bit of an overview of a set before we actually use a set within our sprite lectures that come after this one.